Hi, I'm covering today the second section on chapter 2. That's the section on circles. So by definition, a circle is the set of all points in a plane that are at a given distance That distance is called the radius from a given point, called the center. Okay, so let's say we have a circle on the coordinate system. So we have a circle. By definition, a circle is the set of all points in a plane that are the given distance, the radius, from a given point. Let's suppose that the coordinates of the point are the coordinates of the center are h, k, and x, y is any point on the circle. And the distance from the center. Okay, so I'm going to write the coordinates of the center. So the distance from the center to any point on the circle is going to be the radius. We're going to call the radius r. So r is the radius. And it follows from the distance formula. Using the definition and the distance formula, the distance, which is the radius, is the same from the center to any point. So the distance from any point xy to the center hk is going to be x minus h squared, that is x2 minus x1 plus y2 minus y1. The y coordinates are y and k. So that formula is already correct. But for not to get rid of that square root, most of the time, if you square both sides, most of the time you're going to see it as square both sides. And the way you'll see the formula in most books is x minus h squared plus y minus k squared equals r squared. So this is the center radius form. And I'm going to copy the formula from the book. That's on page 195. A circle with center hk and radius r has equation x minus h squared plus y minus k squared equals r squared, which is the center radius form of the equation of the circle. As a special case, a circle with center 0, 0 and radius r has the equation x squared plus y squared equals r squared. If h is 0, h is 0, we have x minus 0 squared, which is x squared. And if k is 0, we have y minus 0 squared, which is y squared. we're going to do examples. We are going to find the center radius form. Find the center radius form of the equation of each circle described. And we're going to sketch the graph. The first circle has the following characteristics. Has center -4,5 and radius equal to 5. So -4,5 is going to be h comma k. So this is hk, and the radius is r. So let's plug it in. That's going to be x minus -4 squared plus y minus 5 squared equals r squared, where r squared is 5. But x minus -4 is x plus 4 squared plus y minus 5 squared. There's nothing to simplify. We're just going to keep it in the center radius form, and 5 squared is 25. So this is what we got so far. We're going to sketch the graph. Let's see. So the center is -4,5. So I'm figuring out how many tick marks we need. Okay, y values. Yeah, I think I'll need more space. Okay, so I'll bring this up a little bit, and we're going to cut this. Yeah, because I see that I need more space. That's okay. Okay, so let's keep doing that. See what's going on. This froze. Okay, so let's try. Yeah, I'm trying to see if this one freezes. Okay, I think I got it. Okay, so that should be enough. Okay, so we're there. The center is -4,5. So that's -4,5. This is the center. And the radius is 5. So the distance from the center to any point is going to be 5. That is the distance from the center. So let's take 5 units to the right and 5 units to the left. Actually, I need to go one more. So 5 units to the right and 5 units to the left. So that's -4 plus -4 minus 5, that's -9. And then 5 units up. So from 5 through 10, those are 5 units. And from 5 to 0, there are 5 units. And finally, so let's join the dots. So I'm just use the fact that the radius is 5. And there we are. So it's not a perfectly round circle, but yes, the distance, I chose those points because the distance from the center to any point is going to be 5. And number 2, we're going to sketch the graph of a circle with a center at the origin and radius, let's say the radius is 6. So the equation of the circle is going to be x minus 0, which x minus 0 squared. So x minus 0 is x, that's going to be x squared. Y minus 0, that's y, equals 6 squared, which is going to be 36. And we're going to draw the graph. The center is going to be at the origin. And that's 6 units in each direction. Okay, and let's draw the graph. So that's the center at the origin. And let's try to do this. Yeah, I didn't do a perfect scale. So let's suppose that the circle is round. Yeah, this can be challenging sometimes. Okay, I'm going to fix that. And let's say that this is, yeah, let's fix that. Okay, so that's an idea. Okay, we also have the general form of the equation of a circle. If you FOIL the x minus h squared and the y minus k squared, you're going to obtain the general form. So in the example we did, actually I'm copying this, but first, in the example we did, the center radius form of the equation of the circle was x plus 4 squared plus y minus 5 squared equals 25. So let's square the binomials. We have x squared plus 8x plus 16 plus y squared minus 10y plus 25 equals 25. And we can rearrange the terms. So we have 16, so we have x squared. We have x squared and then plus y squared. Those are the terms. Those are the quadratic terms. And then we have plus 8x minus 10y. And then 16 plus 25 is 41. Subtract 25 from both sides. And that's going to be plus 16. Equals 0. Okay, so this type of form is called the general form. And now I'm going to copy that. For some real numbers D, E, and F, the equation x squared plus y squared plus dx plus ey plus f equals 0 can have a graph. That is a circle or a point or is non-existent. So this equation does not necessarily represent a circle. If the radius is 0, it will represent a point. And if for some reason r squared is negative, it doesn't have a representation on the real coordinate system. Okay, so we're going to go backwards. On page 201, we're looking at number 28. Okay, so we're going to decide whether or not the equation has a circle as its graph. And if it does, we're going to describe the graph. So there's that, and we're doing number 28. Okay, decide whether or not each equation has a circle as its graph. This page 201. If it does, give the center and radius. If it doesn't, describe the graph. So this is what we're going to do. We're going to group like terms and complete the square. So that's the same equation. All I'm doing is rearranging terms. We are going to group the terms with x, group the terms with y, and we're going to bring the plus 16 to the other side. So I didn't do anything different. All I did was rearrange the terms, and now we're going to complete the square. So we're looking for a perfect square trinomial. Okay, complete the square of the first group. That is, we're going to divide 8 by 2 and square it. That's 16. And we're going to divide negative 3 by 2, negative 6 by 2, and square it. And remember, we have an equation. So in order to keep things equal, whatever we add to the left side, we need to add it to the right side. So we added 16 and we added 9. We want to keep things equal. That's like a scale balance. So the equation is not affected. And finally, factor x squared plus 8y plus 16 is going to be x plus 4 squared. Y squared minus 6y plus 9 is y minus 3 squared. Negative 16 plus 16 plus 9 is 9. And the center says if it does, decide whether or not each equation has a circle as its graph, and it does. The equation or the graph of the equation is a circle. With center, negative 4, 3. I know this is on the way, but you need to change the sign. So the graph of the equation is a circle with center negative 4, 3 and radius 3. If r squared is 9, then r is 3. And the radius is a distance, so the radius must be, we must take the positive solution. Technically, this has a negative and a positive solution, but we're talking about a distance. If you complete the square and the radius happens to be a negative number, then it doesn't represent anything on the coordinate system. And if the radius is 0, a circle with radius 0, well, that's a point that represents a single point. In the next example, we're going to find the equation of a circle. With center at negative 2, 5. And passing through the point 1, negative 3. Okay, so we know the center and we know a point. Also find the equation of a circle. We're going to find that in center radius form. Or let's write here. So write the equation. In center radius form. Okay, so we know the coordinates of the center, and we know the coordinates of a point. So these two are going to be negative 2, 5 are HK, and 1, negative 3 is XY. We're going to plug it into the equation of the circle, and we're going to find the radius. So we need to find the radius. Or not even that, find r squared. It shouldn't be difficult because x minus h, that's going to be 1 minus negative 2. That's going to be 1 plus 2. Plus negative 3 minus 5 squared. That's going to be the square of the radius. But 1 minus negative 2 it's 1 plus 2. Negative 3 minus 5 is going to be negative 8. So that's 3 squared plus 64 equals r squared. But 3 squared is 9. 9 plus 64 is r squared. So the square of the radius is 73. And the equation of the circle is going to be 1 plus 2, not 1, x plus 2 squared plus y minus 5 squared equals the square of the radius is 73. So this is the equation of the circle in center radius form. And I'm going to do one more example that involves the midpoint formula and the distance formula. We're going to find the center radius form. Of a circle having a diameter with endpoints 1, -2, and 9, 7. Okay, so we know the endpoints of a diameter. We need to find the radius and the center, and it helps always to draw a picture. Okay, so let's say that one diameter has endpoints 1, -2, and 9, 7. So these are the end values of a diameter. I don't know anything else about this circle. So let's try to sketch the graph, sort of. Let's see, that can be challenging, but let's try. Yeah, so we have the equation of a circle, and these are the endpoints of a diameter. So the center is going to be the midpoint of the line segment joining, or it's going to be the midpoint of the diameter. So we got what? We got the point 9, 7, 1, -2, and the radius is not the radius. The center is HK. Okay, so let's use the midpoint formula to find the center. And once we find the center, we're going to use the distance formula to find the radius. Okay, so the center is going to be the midpoint of that diameter. Midpoint formula, this is what? X, or let's call this H. It's 1 + 9/2. And K, it's -2 + 7/2. Okay, so we know the center. We know that the center is 5 5/2. And we're going to find the radius. Use the distance to find the radius. Or, well, if I use the center to find the radius, I'm going to work with fractions. I prefer not to do that. So use the distance formula to find the diameter. And divide it by 2. To obtain the radius. Okay, let's try that. So we're going to find the distance of, or we're going to find the length of the diameter. I'm just going to call it the diameter is the distance from 1, -2 to 9, 7. So that's going to be 9 - 1 squared plus 7 minus -2 squared. So this is 8 squared, the square root of 8 squared. 7 minus -2 is going to be 9 squared. Or 100, not 100. Well, at the end it's 125, but that's square root of 64 plus 81. But 64 plus 81 is 125. So the diameter and the radius is going to be the square of that. Not the square, half of that. Okay, so the final answer, we found the center and we found the radius. And the equation of the circle is going to be x minus 5 squared plus y minus 5 halves squared equals square root of 125 over 2 squared. And finally, square both sides. The equation of the circle in center radius form is going to be x minus 5 squared plus y minus 5 halves squared equals the square of the square root of 125 is 125, and 2 squared is 4. So this is the equation of the circle. Thank you for listening.